All right, y'all. Welcome to lesson 3.2, a little bit more modern atomic theory. You can see here our pictures. If you remember from the last lesson, um, the pictures of the atoms just looked like filled in blobs with not a whole lot of detail. But you can see as we progress through times, things are getting more and more detailed um, as equipment is advancing and theories are advancing. So the next scientist we want to mention is Ernest Rutherford. You watched a video about him in the last lesson. But Ernest Rutherford wanted to explore, remember J.J. Thomson and his plum pudding model, but he wanted to take that a little further. And like you learned in the video, he shot alpha particles at a thin piece of gold foil. You probably have in your kitchen aluminum foil, which is just a really thin piece of aluminum. Well, gold foil, same thing, but with gold. A lot more expensive. Just random trivia. Some fancy restaurants actually put it on their food for people to eat. It's really thin. It's really small. Not going to harm you in teeny amounts, but supposedly super fancy and expensive, right? Anyway, so gold foil. Um, and like we learned, he expected those particles to go right through the foil, straight through. But there was some scattering and bouncing. Um, and his conclusion was that this could only happen if there was a nucleus in the atom, that dense, positive, concentrated center. Um, so he basically came up with the nucleus idea, which was correct, and this is something that we still hold true today. Um, but that was Rutherford, huge contributor to the modern atomic theory with his discovery of the nucleus. The next guy we want to mention is Niels Bohr. You're going to be doing some experiments with some of his type of work in the end of this lesson. But Niels Bohr was the one who recognized that electrons were orbiting the nucleus, but they were only orbiting in very specific places. So there's these stable orbitals. At this point, you can kind of think of an atom like our solar system, right, with the sun at the center and a planet at these stable levels, a certain distance from the center. But those distances were very specific. They weren't like in the plum pudding model, just randomly scattered throughout, right? Um, so those orbitals are specific. They also could be measured by measuring the electron's energy release. Again, we're going to do an experiment showing how this energy is released in a whole lot more detail later on. Um, he also discovered that electrons can only gain energy and lose energy as they're jumping from one of these levels to another. So an electron will gain energy, and move up a level, and lose energy and move down a level, or gain a lot of energy and move up 2 levels, and then lose it and move back down. Um, so electrons can only gain energy and lose specific amount of energy when they jump from one allowed. These are called orbitals to another, just like with planets orbiting, right? These are called orbitals. So electrons can only gain and lose energy moving from one orbital and back down. Um, and lastly, our most modern theory throughout the years, the last 100 years or so, since Niels Bohr, this model has been refined. Um, so now we know that protons and neutrons are found in the nucleus, right? I'm going to abbreviate these P and N just because for space and time. Do what you like. But protons and neutrons are made up of even smaller particles called quarks. So way back when they thought the atom, that's Quarks, right? They thought the atom couldn't be broken down into anything smaller. It can, and even protons and neutrons can be broken down into smaller particles called quarks. Right? Um, Particle physicists study these quarks and how they interact in the universe. It's very fascinating studying. If you want to look that up, I'll probably give you a bonus video to watch on that because it is really interesting. We also know now that the chemical properties of each element depend greatly, I'm going to underline greatly, on the electrons and how they behave. Electron behavior is its own special type of scientific study that is incredibly fascinating. We now know that instead of in levels in specific places, electrons still live in levels. So there's level 1, 2, 3, 4, and on out. But they can be found, let's write this out, electrons are found in orbital clouds. So it's not like the planet circulating the sun in one specific path, but there's a cloud, and they could be anywhere in that cloud at any moment. So the exact location of an electron, L-O-K-T-I-O, I can't spell this morning, y'all. Location. The exact location of an electron can't be measured. We just know probably it's somewhere in this gray area. It's not in one specific spot at one specific time, right? We still use the Bohr model a lot as a visual to understand electrons, but it is a very simple model. But we will talk about it in a lot more detail because it is very helpful to visualize an electron in that way. Okay? So just some more modern ideas about the atom. And now you're going to do a experiment kind of like Rutherford did with his gold foil, except not as expensive as gold foil. Sorry.